Welcome class, and now we are going to be tackling the first of the advanced predicting. This is the fourth of the fifth predictions that we are going to be working with today. Now what makes it advanced is it does not always work, and I'll be explaining that right away. You'll notice I have a lot of things that are listed right over here. There we go. Right over on this side here for you. You will see that I've started each of these three problems that we are going to go over. The single replacement of sodium with aluminum chloride, iron 3 with phosphoric acid, and cadmium with iron 2 nitride. All of the compounds are made and all of the reactants are done, and that of course happened because I canceled all the charges ahead of time. To determine if a single replacement reaction works, we have to look at the activity series, which is straight down below. You will see first is my 5 steps for how to do it if you remember your PowerPoint and the presentations that are available, and you then have this activity series, which I have abbreviated. Now the very first thing about a single replacement reaction is to see if it even works, and to do that we need to see if what was alone is stronger than what was bonded. So we're going to start with sodium and aluminum. If I take a look at sodium and aluminum, we've got sodium is right up here, as you can see. I've got my sodium right here in the activity series, and that is clearly above aluminum, which is, below it right down here. Since sodium is above aluminum, this first one will work. And since it works, I then do my second step. So that was the first step. Second step, write the bonded metal alone. So the aluminum which was bonded is now going to be alone. So I'm going to sit there and I'm going to type in my Al for aluminum. What is then going to happen is the sodium which was alone is now going to be combined with the anion. So that I'm going to be doing in a different color. We've got sodium with a capital N, a little a, big C, little L, and that is sodium chloride, which you may remember as table salt. We do not carry over any subscripts. The 3 chlorines do not carry over because we are canceling this with charges. There is 1 sodium with a 1 charge with 1 chlorine with a 1 charge. 1 and 1 cancels, and so we're good. So NaCl does indeed exist. So that was our cancel charges step. Done. Next, we balance. To balance this, what we are going to be dealing with is 1 sodium, good so far. 1 aluminum, still good. But 3 chlorines to 1 chlorine, not good. So while there are 3 in the reactants, there is only 1 in the products. So I need to change that with a coefficient. This means I have to go and change the sodiums in the reactants to also be 3. That concludes what ended up being a pretty simple single replacement. So let's make it a little more complicated with iron 3 and phosphoric acid. So the iron, as you can see, is right here on the activity series because we need to see if this works. Kind of in the middle, but the hydrogen is lower even than that, which means the iron will replace the hydrogen. This means that it looks like hydrogen is going to be alone. Now for those of you who are experienced with chemistry, you realize the words hydrogen alone are 2 words that should not be together. Hydrogen is social. It is diatomic, meaning it is too reactive to be alone. So in this one instance, it's going to become H2 as opposed to just H. Because it can't be. It cannot be found alone in nature, so we are not going to write it alone in our equation. Now I'm going to then take the iron and I'm going to put it together with the phosphate. The iron is iron 3. The phosphate has a 3 negative charge, but this time I will carry the 4 with me because the 4 in phosphate is a necessary part of that polyatomic phosphate anion. Whew, it's a mouthful. Polyatomic means it was more than 1 atom, anion is negative, and thus that little 4 has to carry over. You'll notice the 3 for the hydrogens did not carry over because it is not a polyatomic, thus it doesn't carry over. Polyatomic carries, no polyatomic, no carry. So then I check, okay, it's made 3 plus, 3 negative, cancels, we're good there, so it is now time to do our balancing. So the ions look good at first. Move to the hydrogens. I have 3 hydrogens in the reactants, 2 in the products. So I'm going to make them both into 6. 3 and 2 become 6, and that makes our life nice and happy. Then as I look, I've got 1 iron, 1 phosphate, 1 phosphate, or 1 phosphorus, 4 oxygens, 4 oxygens. Either way you do it, that's balanced. That's all we needed to do there. Then I go to the next one. Again, I must check if it works. If I do not check whether it works or not, I don't know if I'm going to do a lot of work for no reason. And as I look here, cadmium, which is, right here, I mean, there's cadmium right here. Cadmium is not above iron. It's not. Iron is above cadmium, which means I'm done. There's nothing I can do. This will not work. All I have to do is type capital N, capital R for no reaction, and I'm good. That's it. So if you check to see if something works or not, you can save yourself an awful lot of headache later, because if it doesn't work, it's just NR. Take care and stay safe, class. Till next time.